A blessed morning, dear students. Welcome to another session of Valenzuela Live Mathematics 7. We are now in week 5 of quarter 3. Are you familiar with polygons? Look around. You might be surprised to find out that there are a lot of polygons or polygonal shapes around you. Today's lesson, we are going to study how to illustrate polygons according to its convexity, angles, and sides. At the end of this session, you are expected to define a polygon, illustrate the different classifications of polygons, determine the number of diagonals of a convex polygon, classify a given triangle according to sides and according to angle, and illustrate the different kinds of quadrilaterals. For our first activity, let us see what you already know about polygons. You are going to write yes if the given figure is a polygon, and no if not a polygon. Are you ready? Let's begin. You have 5 seconds to key in your answer. Number 1. 5 seconds. Go. Correct answer is yes. Number 2. 5 seconds. Go. The correct answer is no. Number 3. 5 seconds. Go. Correct answer is yes. Number 4. 5 seconds. Go. Correct answer is no. Number 5. 5 seconds. Go. Correct answer is no. Number 6. 5 seconds. Go. Correct answer is yes. Number 7. 5 seconds. Go. Correct answer is no. Number 8. 5 seconds. Go. Correct answer is yes. Number 9. 5 seconds. Go. The correct answer is no. Number 10. 5 seconds. Go. Correct answer is yes. Polygon is a closed plane figure made up of 3 or more line segments joined at their endpoints. The word polygon came from Greek words poly, which means many, and gonia, which means angles. These are the following examples of polygons. You can see all of these are closed plane figures made up of 3 or more line segments joined at their endpoints. And the following figures are not polygons. Take note that if the figure is not closed or figure has curved part, then it is not a polygon. A polygon has 3 primary parts, namely sides, the vertices, the plural of vertex, and the interior angles of the polygon, wherein the segments itself is the side of the polygon and the common endpoints of the segment is the vertex, while the angle formed at the vertices inside the polygon are the interior angles. For example, we have here a polygon. In our given polygon, the sides are segment FA, segment AI, segment IE, segment PH, and segment HF. The vertices are points F, A, I, T, and H. The interior angles are the following: angle F, angle A, angle I, angle T, and angle H. Polygons are named by writing the consecutive vertices either in clockwise or counterclockwise direction. Or the given polygon can be named as pentagon FAITH or pentagon FHTIA or pentagon HFAIT or pentagon HTIAF. Polygons can be classified according to its convexity. There are 2: convex polygon and the non-convex polygon. If segments are drawn connecting any 2 points of the polygon, and all the segments lie entirely inside the polygon, then the polygon is a convex polygon. And if some parts of the segment drawn lie outside the polygon, then the polygon is a non-convex polygon. Also, polygons can be classified according to the number of sides. A 3-sided polygon is called a triangle. A polygon with 4 sides is called a quadrilateral. A 5-sided polygon is a pentagon. A polygon with 6 sides is a hexagon. A 7-sided polygon is a heptagon. A polygon with 8 sides is an octagon. A 9-sided polygon is a nonagon. A 10-sided polygon is a decagon. A polygon with 11 sides is called a decagon or hendecagon. A polygon with 12 sides is called a dodecagon. A 13-sided polygon is called a 13gon. For polygons with 13 or more sides, use the pattern n-gon to name the polygon. For example, a polygon with 23 sides is called 23-gon. Let us now proceed with a regular polygon. Remember this, a polygon is only said to be regular if and only if it is both equilateral and equiangular, meaning all sides are congruent and all angles are also congruent. To show congruency of or equality of measures between the sides or between the angles of a given figure, tick marks are usually drawn. And among the members of quadrilaterals, square is the only regular polygon. Let us now proceed with activity number 2. Choose the correct illustration of the polygon being described. Write only the letter of the correct answer in the comment box below. You have 5 seconds to give your answer. Number 1. A convex octagon. Is it letter A, letter D, or letter S? 5 seconds, go! Correct answer is D. Number 2. A non-convex quadrilateral. Is it letter A, letter S, or letter B? 5 seconds, go! Correct answer is letter A. Number 3. A convex hexagon. Is it letter S, letter B, or letter E? 5 seconds, go! Correct answer is letter B. Number 4. A non-convex decagon. Is it letter S, letter E, or letter M? 5 seconds, go! The correct answer is letter S. Number 5. A non-convex nonagon. Is it letter M, letter Y, or letter K? 5 seconds, go! The correct answer is Y. Were you able to answer them all correctly? Well done, children. Let us now proceed with diagonal. A diagonal is a segment connecting any two non-consecutive vertices of a polygon. Quadrilateral has only 2 diagonals. Segment HP and segment EO are diagonals of quadrilateral HOPE. Now, will you get your notebook and pen and try to draw and count the number of diagonals that can be drawn in each convex polygon? Typically, pentagon, hexagon, and heptagon. Were you able to count how many diagonals do they have? In pentagon, it has 2 plus 2 plus 1. A pentagon has a total of 5 diagonals. In hexagon, it has 3 plus 3 plus 2 plus 1. A hexagon has a total of 9 diagonals. In heptagon, it has 4 plus 4 plus 3 plus 2 plus 1. A heptagon has a total of 14 diagonals. But what if I ask you how many diagonals are there in a convex 50gon or in a 100-sided convex polygon? Can you easily identify the number of diagonals? Now take a look on our first 3 examples. From one vertex, we can only draw 2 diagonals in a pentagon, 3 in a hexagon, and 4 in a heptagon, which can be obtained by subtracting 3 from the number of sides or the number of vertices a polygon has. Why subtract 3? Simply because we cannot use one vertex and the other 2 vertices that is adjacent to it to form a diagonal. As you can see in a pentagon, there are only 2 diagonals in every vertex, 3 diagonals in hexagon, and in heptagon, 4 diagonals in every vertex. Multiplying the number of diagonals that can be drawn in one vertex to the number of vertices of a polygon, we have 5 times the quantity of 5 minus 3, 6 times the quantity of 6 minus 3, and 7 times the quantity of 7 minus 3. But only half of these diagonals were actually drawn. That is why we have to divide this product by 2, so as not to repeat the count of the diagonals and obtain the number of diagonals that we have actually drawn. Replacing the number of sides of the polygon with n, we now have the formula for the number of diagonals, which is n times the quantity of n minus 3 all over 2, wherein n is the number of sides of a polygon. Again, to find out the number of diagonals in a polygon with n sides, use the formula n times the quantity of n minus 3 all over 2, where n is the number of sides of the polygon. Let us now proceed with activity number 3. In this activity, you are going to use formula n times the quantity of n minus 3 all over 2 to determine the total number of diagonals of the following polygon. Are you ready? You have 5 seconds to key in your answer. Number 1, a decagon. 5 seconds, go! Correct answer is 35 diagonals. Number 2, nonagon. 5 seconds, go! Correct answer is Anagon has 27 diagonals. Number 3. 13 gone. 5 seconds. Go. Correct answer is 65 diagonals. Number 4. Octagon. 5 seconds. Go. Correct answer is 20 diagonals. Number 5. 15 gone. 5 seconds. Go. Correct answer is 90 diagonals. You get them all correct? That's great. Let us now proceed with the next lesson, the triangle. Triangle is a three-sided polygon. For example, we have triangle ABC. Sides of triangle ABC are segment AB, segment BC, and segment CA. The vertices of triangle ABC are points A, B, and C. The interior angles of triangle ABC are angle B, and angle C. Triangles can be classified according to sides and according to angles. There are 3 different kinds of triangles according to sides. First is the iscalene triangle, which has no 2 sides congruent, or a triangle that has 3 unequal sides. It may be drawn with no tick marks or with 3 different number of tick marks. Second, the isosceles triangle, which has at least 2 sides congruent. Lastly, the equilateral triangle, special type of isosceles triangle with 3 sides congruent. Next, triangle according to angles. First is the acute triangle. Triangle in which all of the 3 angles measures less than 90 degrees. Second is the right triangle. A triangle in which one of the angles measures 90 degrees. Third is the obtuse triangle. Triangle in which one of the angles measures more than 90 degrees. Lastly is the equiangular triangle. Special acute triangle where all angles are congruent. Can you guess the measure of each angle? Very good. Each angle measures 60 degrees. Let us now proceed with quadrilateral. Quadrilateral is a 4-sided polygon. There are many kinds of quadrilaterals. Let's begin with the trapezium. Quadrilateral with no pair of opposite sides parallel. Next is the trapezoid. A quadrilateral with one pair of opposite sides parallel. We also have the parallelogram. A quadrilateral with 2 pairs of opposite sides parallel. And its opposite sides are congruent. Next, the rectangle. parallelogram with all angles measures 90 degrees. Rhombus. A parallelogram with all sides congruent. Where? A parallelogram with congruent sides and congruent angles. Lastly, the kite. A quadrilateral with two pairs of adjacent sides congruent. Let us now proceed with the last activity entitled Mission Possible or Impossible. The mission is to illustrate the figure being described. What to do? You're going to write possible or impossible to accomplish the mission. Are you ready? Let's begin. You have 5 seconds to key in your answer in our comment section. Number 1. Quadrilateral with one pair of parallel sides and with 2 right angles. Possible or impossible? 5 seconds. Go. The correct answer is possible. Number 2. A triangle with measures of sides 7 centimeters, 7 centimeters, and 18 centimeters. Possible or impossible? 5 seconds. Go. Correct answer is impossible. Why? Because even if we connect segments which measure 7 centimeters end to end, it will not meet the other end of the segment which measures 18 centimeters to form a triangle. Number 3. An isosceles right triangle. Possible or impossible? 5 seconds. Go. Correct answer is possible. Number 4. A quadrilateral with 4 acute angles. Possible or impossible? 5 seconds. Go. Correct answer is impossible. Why? Because a quadrilateral can have at most 3 acute angles, but not 4. Number 5. A quadrilateral with 3 sides congruent and with 3 obtuse angles. Possible or impossible? 5 seconds. Go. Correct answer is impossible. Why? Because a quadrilateral may have 3 congruent sides, but not with 3 obtuse angles at the same time. To sum up the important points of our today's lesson, polygon is a closed plane figure made up of 3 or more line segments joined together at their endpoint. A polygon is convex if all segments joining any 2 points of the polygon lie completely inside the polygon. Otherwise, the polygon is non-convex. A polygon is regular if all sides and all angles are congruent. Polygons can also be classified according to the number of sides. And to determine the number of diagonals of a polygon, we can use the formula. Number of diagonals equals n times the quantity of n minus 2 all over 2, where n is the number of sides of the polygon. Triangles may be also classified according to sides: plane, isosceles, or equilateral triangle, and according to angles, as acute, right, obtuse, or equiangular triangle. Quadrilaterals is a four-sided polygon. There are different kinds of quadrilateral: trapezium, no pair of opposite sides parallel; trapezoid, with one pair of opposite sides parallel; parallelogram, with two pairs of opposite sides parallel; and kite, with two pairs of adjacent sides congruent. To check your understanding about our lesson for today, try to answer the following activity as your homework. Just write true or false. If you have other questions, you may ask your subject teacher during the follow-up discussion. And before we end, I would like to share this quote of Sir Mark Twain: "A round man cannot be expected to fit in a square hole right away. He must have time to modify his." And that ends our discussion for today. This is Mom Michelle Ortiz of General Tiburcio de Leon National High School. Thank you. God bless everyone.